Okay, so we have our first sort of really obvious paradox here. That is the notion that the um, the clock in the enterprise appears to run slow for an observer on Earth. At the same time, a clock on Earth appears to run slow for an observer on the enterprise. Okay, so that paradox is obviously non-intuitive and a bit confusing, and we're not going to discuss that right now, but we will get back to that in one of the next couple lectures. The third consequence of Einstein's postulates is length contraction. Here, the length of an object in a frame through which the object moves is smaller than its length in the frame in which it is at rest. So the length of the enterprise, according to an earthbound observer, is shorter than the length of the enterprise as measured by the people who are in it as it hurtles through space. To illustrate length contraction, let's first imagine that the enterprise here, which has what we call a proper length, L0 or L0, that is its length as measured in its own rest frame, that when it's in space dock, maybe when it was being built, that it was in a hangar, this sort of tent looking thing here, and let's imagine just for argument's sake that they built this hangar to be exactly the same length as the enterprise, so that it just accommodates the enterprise, so that the length of the hangar between these two columns here, L, is also equal to L0. Now let's consider the situation when the enterprise is now moving rapidly, and if it happened to fly by the place where it was built, this hangar, which still has a length in the hangar's rest frame, its length is still equal to the proper length of the enterprise. But now in the hangar's rest frame, the enterprise, as it moves with velocity v, looks shorter, and therefore it would be able to, if it flew through the hangar, instead of just accommodating the enterprise as it did before, there would be room to spare for the enterprise within the hangar. As I've drawn it here, there's plenty of room to spare. Okay, now I should point out to the people in the enterprise, they still observe the enterprise as being of length L0. So again, to the people within the enterprise, they're within the rest frame of the enterprise, and so to them, they still see the enterprise as being the same length, L0, but to the people on Earth, or the people at least that are workers that are on the hangar, they see the enterprise as being shorter when it's moving past the hangar. Okay, but what about symmetry? What happens if we consider the same situation, the enterprise moving in the reference frame of the enterprise? So in this case, in the rest frame of the enterprise, then the enterprise, of course, its length is L0. But now the hangar looks like it's moving to the left with velocity v, and it looks like it is smaller than to the enterprise, to people on the enterprise. The hangar is shorter than its rest length, L0, and now the enterprise is too long and it won't fit. So who's right? Which frame is the preferred frame?